Scientists just built this tiny artificial leaf that turns sunlight into fuel. Past attempts at building artificial photosynthetic systems have suffered from high catalytic overpotentials and insufficient semiconductor photovoltage, which is a complicated way of saying that even though nature can do it, we can't produce enough power from photovoltaics to split carbon and oxygen atoms in CO2. To overcome this challenge, researchers built a device 200 times more efficient than past approaches by combining a bismuth vanadate photoanode with a perovskite photocathode to generate as high a photovoltage from the sun as possible. As sunlight hits the layer of bismuth vanadate, light from the UV to blue end of the spectrum is absorbed, while the remaining light continues deeper into the device until it strikes the perovskite photocathode. This layer is capable of absorbing the remaining visible to infrared light. This generates a higher bandgap electron than a normal solar panel. This energy is directed to an array of tiny copper nanoflowers that are on the back surface, formed into thin petal-like extensions to maximize their surface area. These energized nanoflowers are capable of splitting CO2 into useful short-chain hydrocarbons that can be then made into liquid fuel and chemicals, taking inspiration from nature even if we do make it look kind of difficult. Using these sorts of fuels would mean that CO2 is put into a closed loop. Burning these fuels releases CO2 into the atmosphere, but then we would pull it straight back out again to turn it into more fuel, and never again would we need to drill under the ground to look for oil. This is broadly the peak of all human ingenuity, all to replicate just something that nature has been doing for millions of years.
What would they need to mimic a fraction of our power?
If you like science and praising the sun, follow for more. Scientists just built this tiny artificial